Hello, welcome to Brilliant Kuwait. Today we are discussing questions from structure of atom. These questions are previous year JEE questions. According to Bohr model of hydrogen atom, which of the following statement is incorrect? The options they are given. Radius of 6th orbit is 3 times larger than that of 4th orbit. B option, radius of 3rd orbit is 9 times larger than 1st orbit. The radius of 8th orbit is 4 times larger than that of 4th orbit. The radius of 4th orbit is 4 times larger than the 2nd orbit. Actually, they are asking the question, which of the statement is incorrect? Then how we can solve this question? If you know the equation, that is Rn, radius of nth energy level, is equal to A0 n square divided by Z. This is hydrogen, that's why Z is equal to 1. Z is equal to 1. And n is varying there. So if you are adding the value, we will get the correct answer. The first option, we can see that the ratio between 6th and 4th, it is given that 3 times. But if you are taking n square, that is 6 square divided by 4 square, that is R6 divided by R4, that is equal to 36 divided by 16. It is 2.25. It is not 3, right? Then what about the next option they are given? The next option they are given, the ratio of 3rd and first one. 3rd one is 3, first is 1. That's why 3 square divided by 1 square, 9 divided by 1, that is equal to 9 is the answer, right? It is 9 times, it is given. That's why this statement is correct. A statement is wrong. Second statement is correct statement. Third one is, that is the relation between 8th and 4th orbit. 8 square divided by 4 square, 16, 64 divided by 16. That is equal to 4. That's why this option also correct. Then last option they are given, that is D option, that is 4th to 2nd. 4 square divided by 2 square, that is 16 divided by 4, it is 4, that is, it is 4 times, right? So which is the correct answer here? The incorrect statement they are asking, that's why A is the correct answer. Next question, the extra stability of half-filled subshell is due to, they are given 5 reasons. A, symmetrical distribution of electrons. B, smaller Coulombic repulsion energy. C, presence of electrons with the same spin in non-degenerate orbitals. D, larger exchange energy. E, relative smaller shielding effect of electron by one another. Which statements we can take correct? Here, first is symmetrical distribution of electron is correct. Smaller Coulombic repulsion energy is correct. The presence of electrons with the same spin in non-degenerate orbitals. Actually, half-filled subshells they are telling, right? It is degenerate. And large exchange energy, relative smaller shielding effect of electron by one another. So here, the statement A, B, C, D, E, from this, apart from C, other statements are correct. So which option we can take? D option. A, B, D, E are correct. So D option is the correct answer. Next question. Which of the following postulate of Bohr's model of hydrogen atom is not agreement with quantum mechanical model of an atom? Here also they are given 4 options. First option, when an electron make a transition from higher energy level to lower energy state, it emit photon of light. Second, they are given, an atom can take only certain distinct energies, E1, E2, E3, etc. These allowed states of constant energy called stationary state of atom. And third statement they are given, the electron in hydrogen atom stationary state moves in a circle around the nucleus, and Last statement they are given that an atom in a stationary state does not emit electromagnetic radiation as long as it stays in the same state. We already know that according to Bohr atom model, when an electron remains in a particular energy level, it does not emit or absorb energy. We already know that central nucleus is there, electrons are revolving around the nucleus in a circular path, right? As long as an electron in a particular energy level, it does not emit or absorb energy. Then which statement we can take according to the question? Which of the following Bohr postulates of Bohr model of hydrogen atom not agreement with the quantum mechanical model they are asking, right? So the option C is the correct answer, because the electron in a hydrogen like atom or hydrogen atom, the stationary state, the electrons are moves in a spherical path. Here they are given C statement in a circular path, right? So C is the correct answer. Heat treatment of muscular pain involves radiation of wavelength about 900 nanometer. Which spectral line of hydrogen atom is suitable for this? Here they are given Rydberg constant in centimeter inverse, it is 10 raised to 5, and Planck's constant they are given H is equal to 6.6 into 10 raised to minus 34 joule second, right? Then C also given, that is velocity 3 into 10 raised to 8, 3 into 10 raised to 8, that is meter per second. Then they are given the option, this is a transition from infinity to 1 in Lyman series, then Balmer series infinity to 2, and Paschen series 5 to 3, and Paschen series infinity to 3. Here the wavelength they are given 900 nanometer, right? Then what is the equation we can use for this numerical? Rydberg equation, right? RH into 1 by n1 square minus 1 by n2 square, right? It is actually equal to 1 by lambda or nu bar. Here wavelength is 1 by lambda, right? But here we have to find equal to 900 nanometer. Then which transition may be? See, if it is n1 is equal to 3, it may be 9, right? Then infinity, that's why which equation we can take here? That is the transition from Paschen series, that is infinity to 3, right? That is, if we are taking in this equation, substituting in this equation, 1 by lambda is equal to RH into 1 by n1 square minus 1 by n2 square, that is 10 raised to 7, 1 by 3 square minus 1 by infinity. RH we already know that 10 raised to 7 meter raised to minus 1, right? Then 1 by lambda is equal to 10 raised to 7 into 1 by 9. Then lambda is equal to 9 into 10 raised to 7, that is 900 nanometer. Then which is the correct answer here? D is the correct answer. Next question. Radius of the first excited state of helium ion is given as A0. Radius of first stationary state of hydrogen atom. That is, what is first excited state? If it is stationary, if it is they are given a specific state, we can take it is 1, right? It is actually helium they are telling, that's why atomic number is 2. If it is first excited state, n is equal to 2. Then what will be the equation we can use for this numerical? Here we already know that radius Rn is equal to A0 n square divided by Z, right? Then here it is n is equal to Z is equal to 2. So what will be the answer? R is equal to A0 into n square divided by Z. Here A0 into 2 square divided by 2. That is equal to R is equal to 2 is A0. So what is the correct answer here? Here A is the correct answer, students. Next question. Here you can see that the question is, if A0 denoted as the Bohr radius of hydrogen atom, when what is the de Broglie wavelength lambda of the electron present in the second orbit of hydrogen atom, any integer, right? Then they are given 4 options. In this question, how we can calculate the de Broglie wavelength and how we can connect with the Bohr radius? We already know that Bohr radius Rn equal to, that is A0 n square divided by Z, right? So if you are applying here n is equal to, that is actually given that A0 is denoted as the Bohr radius of hydrogen atom, when what is the de Broglie wavelength lambda of the electron present in the second orbit of hydrogen. So n is equal to 2. It is hydrogen, that's why Z is equal to 1. So we can take R2 is equal to, R2 is equal to 2 square A0, that is equal to 4 A0 we will get, right? Then what will be de Broglie wave equation? We have to substitute the value in de Broglie wave equation. Before that, we have to find how the R is related to de Broglie, right? Then how we can take, we already know that angular momentum of electron in a particular energy level is given by MVR is equal to NH by 2 pi. From there, we can take the lambda, that is lambda is equal to H by mv. So 2 pi r divided by n we will get. Then lambda is equal to 2 pi r divided by n. So 2 pi into r we already know that. So 2 pi into 4 a0 divided by n. So it will be, it will be equal to, that is 8 by a0 divided by n. Then what is the correct answer? C is the correct answer, students. Next question. Here they are given two statements. First statement is, it is impossible to specify simultaneously with arbitrary precision both linear momentum and position of a particle. Statement 2, if uncertainty in the measurement of position and uncertainty in the measurement of momentum are equal for the electron when the uncertainty in the measurement of velocity, then what is the equation for uncertainty according to Heisenberg uncertainty principle? Delta x into delta p is greater than or equal to h by 4 pi, right? Then how we can calculate this equation? Yes, here we already know that this is the equation, right? So here they are given uncertainty in velocity, right? Then how we can calculate this? If delta p is equal to delta x, uncertainty in position and uncertainty and momentum are equal, from there only we have to calculate the uncertainty in the velocity. So we have to take delta p and delta x are equal. So delta p square is equal to or greater than or equal to h by 4 pi, right? Then delta p is m into delta v, right? That is equal to h root of h by pi into half. That is equal to delta v is equal to root of h by pi into 1 by 2m. That only they are given here, right? So both the statements are correct. So which is the correct option here? Both statement 1 and 2 are correct. So A is the correct answer. Next question. Which of the following statements are true? Here they are given 4 statements. First one is the subsidiary quantum number L describes the shape of the orbital occupied by electron. And B they are given, that is 3 axes, in X double shape is given, right? It is the boundary surface diagram of 2px orbital, right? It is 2p, right? 2px. Then C they are given the plus and minus sign in the wave function of the 2px orbital refer to charge they are telling. The wave function of 2px orbital 0 everywhere in xy plane. They are given options A. Option A is B and D only. Option B they are given A, B and C only. And option C they are given A and B only. And option D they are given C and D only. But what is the question? Which of the following statements are true? The first statement, the subsidiary quantum number L describe the shape. We already know that the quantum number N, L, M, L and MS, right? This is principal quantum number size and azimuthal quantum number shape, and that is then magnetic quantum number, orientation, and spin quantum number, it telling about the spin of the electron. So it give the shape, right? So this is correct. Subsidiary quantum number L describe the shape of the orbital occupied by electron, and B they are given, it is this double dumbbell in x axis, right? So it is px orbital. So A and B are correct. And what about the C statement? The 1 and 2 plus and minus sign, it is given that the plus and minus sign in the wave function of 2px orbital refer to charge. It do not refer the charge, right? Yes, that's why this statement is wrong. So what is next statement? 2ps orbital 0 everywhere in xy plane. Actually it is not in xy plane, right? It is actually this statement also wrong. It is in yx plane, right? YZ plane. So this is the answer. Correct answer is A and B are correct. What is the correct answer here? C is the correct option here. Next question. For electron in 2s and 2p orbitals, 2s and 2p orbitals, the orbital angular momentum values respectively are. What is orbital angular momentum? We know the equation for orbital angular momentum, root of L into L plus 1 into h by 2 pi, right? So here 2s and 2p, right? So what will be the L value? 2s means that is n value is 2, L value is 0, and 2p n value is 2, L value is 1, right? So then what will be the answer here if you are substituting the L value here? The first case you can see that L is equal to 0. If you are applying that L is equal to 0, then it will be 0, right? So the orbital angular momentum first is 0, so it may be C or D. Then if you are applying the L value 1, root of 1 into 1 plus 1 h by 2 pi, right? That's why root 2 into h by 2 pi, right? So what is the correct answer here? D is the correct answer according to the question. Next question. Consider the ground state of chromium atom. Its atomic number they are given 24. How many electrons are with the azimuthal quantum number L is equal to 1 and L is equal to 2 respectively? We already know that the electronic configuration of chromium, we are expecting one electronic configuration, but the actual electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, then 4s1, 3d5. That is the actual electronic configuration. There they are asking L is equal to 1 and L is equal to 2. L is equal to 1 means it is P subshell, right? And L is equal to 2 means it is D. Then how many electron in P and D? P and D, right? So how many electron in P and D? Yes, in P it is 12 electrons and D it is, here you can see 5 electron, right? So which will be the correct answer? 12 and 5. D is the correct option. Next question. Correct statements for element with atomic number 9 are. Here they are given 4 statements. There can be 5 electron for which ms value plus half and 4 electron with the ms value that is minus half, that is spin quantum number, right? Then there is only 1 electron in pz orbital, and C, the last electron go to orbital with the n is equal to 2 and L is equal to 1. The sum of angular node of all the atomic orbital is 1. Choose the correct answer from the options given below. And what are the correct options, students? How we can find this one? This time you have to check what are the correct statement. First one is they are given. Before that you have to understand the electronic configuration, right? The atomic number they are given 9. So the electronic configuration will be, that is 1s2, 2s2, 2p5. So 1s2 how many electron? 2 electron. 2s2 how many electron? 2 electron. 2p5 means, yeah, first 3 then plus 2, right? 5 electrons are there. Then there are 5 electron with a ms value plus half. We will check 1, 2, 3, 4, 5. Yes, first statement, first half is correct. And 4 electrons with a ms value minus half. 1, 2, 3, 4. So first statement is correct statement. Second, there is only one electron in ps orbital. That we cannot predict, right? So it may be px, it may be py, it may be pz. That's why B statement is wrong. And third one is the last electron go to the orbital n is equal to 2, n is equal to 2 and L is equal to 1. Yes, it is 2p, right? So that statement is correct. Then the next statement, the sum of angular node of all atomic orbital is 1. It may be wrong, right? Because we already know that there are 3 orbitals are there. So which is the correct answer? A and C. So A option is the correct answer. Next question. This also statement type question. Given below are 2 statements. Statement 1, for a given shell, the total number of allowed orbital is given by n square. The statement 2, for any subshell, the spatial orientation of the orbital is given by minus L2 plus L value including 0. We already know the quantum number is, right? If quantum number for we know that its value how we are taking, right? For a given shell, the total number allowed orbital. Okay, we will check n is equal to 1. So energy level 1, right? How many orbitals are there? That is 1 square. It is equal to 1. Yes, it is S, only S is there, right? If you are taking n is equal to 2, it is 2 square. It is 4. In second energy level, L value 0 and 1. 0, we know that it is S, it is P. S our 0 orientation. P may be minus 1, 0 plus 1. Total 4. So this statement is correct, right? And second one is, for any subshell, the spatial orientation of the orbital is given by minus L2 plus L including 0. That statement also correct. So first statement, both the statement, first and second are true. So B is the correct answer. Next question. For hydrogen atom, the orbitals with the lowest energy is or are for us 3px, 3p square y square, then 3dz square, and they are given 4pz. Choose the correct answer from the options given below, right? Here, in the case of hydrogen, we are mainly discussing the energy level, first energy level, second energy level, third energy level, like that. So first energy level 1s is there. In second energy level 2p and 2s is there. Third energy level 3s, 3p and 3d. And fourth energy level 4s, 4p, 4d and 4f is there, right? So here you can see that is 3, 3, 3. This is actually 4, right? So B, C and D we can take. So which is the correct option? Yes, the option correct is, that is D option. Next question. In a multi-electron atom, which of the following orbital described by 3 quantum numbers will have a same energy in the absence of electric and magnetic field? Here you can see that in A, B, C, D and E they are given. In A, n is equal to 1, n is equal to 1, L is equal to 0 and M is equal to 0. In second case, n is equal to 2, L is equal to 0, M is equal to 0. And third case, you can see that n is equal to 2, then L is equal to 1 and M is equal to 1. Here you can see in first case N is equal to 1. N is equal to 1 means first energy level, L is equal to 0 means 1s, right? And second one is 2s. Third one is 2p, right? And third and fourth we can see that N is equal to 3, that is third energy level, and L is equal to 2. L is equal to 2 means D subshell, right? And M1 is equal to ML is equal to 1. That may be one orbital from D subshell, right? And second you can see in the E option, E statement we can see that this also 3D, right? So the question is choose the correct answer from the options given below using the question which have a that is same energy, the same energy for these two, right? So D and E are the correct option. That's why B is the correct option according to this question. Next question. Which of the following is or are not correct with respect to energy of atomic orbital of hydrogen atom? Same type question we discussed earlier. Based upon we can discuss this question easily, right? In the case of hydrogen, we are looking only the main energy level order, right? First one, second, third, fourth. Here you can see first, second, these two are same, third, these two are same, right? First, second, then greater than is given, that's why it is wrong, right? And first, second, fourth, then third they are given. That's why this is also wrong. So what is the correct answer here, students? A and B. Which option is A and B? Yes, A and B only is B option. So B is the correct answer. Next question. The energy of an electron in first Bohr orbit of hydrogen atom is minus 13.6 electron volt. The magnitude of energy value of an electron in the first excited state of B3 plus is in electron volt we have to calculate. How we can calculate, students? We already know according to Bohr equation how we can calculate the energy En is equal to minus 13.6 Z square divided by Z square divided by N square electron volt, right? If you have what is Z and N here, yes, we already know that this is actually the energy of an electron first Bohr orbit of hydrogen atom is there given, right? That is 13.6. 13.6 already given, right? Minus 13.6. Then the magnitude of the energy value of electron the first excited state. If first excited state means N is equal to 2. We already discussed one question, and this is beryllium, right? Beryllium 3 plus, that's why atomic number is equal to 4. If you substitute the value, what will be the answer? Yes, 13 minus 13.6 Z square divided by N square, that is equal to, that is 4 square divided by 2 square, it is equal to 16 divided by 4. So the answer is minus 54.4. So 50.4 is the correct answer. Next question. In case of isoelectronic species with the size of F minus, Ne and Na plus affected by. What is isoelectronic species? Isoelectronic species means they have same number of electron. F minus means you already know that fluorine 9 plus 1 10. Neon also have a 10 electron, and Na plus 11 minus 1, that is equal to 10 electron, right? So what are the factors affecting they are asking, right? Principal quantum number N. The electron interaction in the outer orbitals. Then nuclear charge. None of the factors because their size is the same. Then what is the answer we can take here? Here we can take the answer the size, right? Nuclear size and charge are related, because you can see that when size increases, when charge increases, size will be reduced. So which option we can take? C is the correct option.